Hi, my name is Marcus Beck. I am the program scientist for the Tampa Bay Estuary program. And in this presentation, I'm going to tell you about our Seagrass Transect data, why it's important, what we use it for, and how training helps us improve these data over time. So we have several partners that have helped us collect these data over the years, and it's really important for us to communicate why these data are important and how our partners are critical to this effort in getting this information. Through the efforts of our partners, we have over 20 years of data collected at transects throughout Tampa Bay. On the right, we see these transects in which monitoring agency has been responsible for collecting this information. Briefly, this information is important for assessing status and trends of seagrass growth over time, how that information relates to water quality patterns collected in other data sets, and how we use this transect data and seagrass data in general as an indicator of program success to track goals and objectives that we have. So this long-term data set is really important for not only tracking status and trends, but the training efforts we do every year is really critical for making sure that data are collected accurately and consistently. So through training, we want to make sure that all of our field crews that are responsible for collecting this information are basically collecting similar data so that it's consistent and accurate. So we ask questions about whether or not the seagrass metrics are accurate and precise through training, and in the end we want to make sure we have confidence in the data as a result. So training helps us assess how reliable the information is. So the basic question we have is, if we send out crew from each one of our partner agencies to the same location, do they assess this information similarly? So this is just showing us a simple quadret of seagrass, and we want to make sure that Tampa Bay Watch, for example, is assessing this the same way as Pinellas County, or the Tampa Bay Estuary program is assessing it the same as the city of Tampa. This is the way we make sure that we all collect the same data. So before training, we might see something like this, where here we're looking at one site with one species and looking at how different crews or different monitoring agencies are assessing abundance differently. So this is a less than ideal situation where each crew is giving us different information about abundance. So in this case, we have low confidence in the data because, again, each crew is giving us different information. After training, the idea is that each crew is going to assess that information the same. So there isn't variation between crews that's leading to different results in the data. So through training, we hope to achieve this. So we use the training data when we're done to evaluate how accurately each crew is assessing the information. We've actually set up a website to input the data and evaluate how well the crews are doing. So with this information, we can assess how consistent the metrics are. So are there particular metrics that are problematic, that are more variable than others? Or we can assess how well each crew is doing in general. And as a result, we can use this information to inform where we can focus training in the future. So if we know that one particular metric is causing problems, we can focus efforts there moving forward, as opposed to other metrics that might be more consistently assessed. So we're looking at the website now, and I just want to briefly walk through what you see on the website. This is something that we use at the Estuary program for ourselves, but it's also something that you guys can use to view how well each crew is comparing across the metrics. Right now, the website has random data on there. When the training is done, we'll populate the website with actual data that you guys have collected. So the first page you land on is a page that lets you look at one particular metric for one particular species at one particular site. And you can select which one you want to view, and at the bottom you see a bar plot of what that variation is across the crews. So how one crew measured abundance, for example, relative to another crew. And again, the idea is that there should be fairly minimal variation between the crews if training has been successful. We can also look at a summary of all of the metrics as a measure of the coefficient of variation, which is basically a relative way to look at which metrics are more variable than other metrics. And this is critical information that synthesizes the variation overall across the data set to let us basically understand which metrics are more variable than others. And this is where we can focus efforts into the future on training particular measures that might be more variable. There's also supplementary information about which crews were assigned to each monitoring agency. There's a map of the transect locations and which crews collect data at a particular transect. And there's also a download tab where you can download all of the figures as a PDF file for your own viewing pleasure. So that's a little bit about training. When this is done, we will combine the annual transect data with other data sets to get a more holistic picture of what's going on with seagrass in the bay. So one particular example is we can link this with the aerial coverage maps provided by the district to get an idea of how, for example, seagrass species are changing with the aerial extent, how the seagrass density is changing with coverage as well, and also looking at temporal changes between the data sets. So again, we have this long-term record for the transect data that we can compare with the long-term record for the coverage data to get a big, broader picture of how seagrass health is changing in the bay over time. And linking it back to water quality, the entire management paradigm for water quality in Tampa Bay basically states that nutrient loads affect water clarity, which in turn affects seagrass. So seagrasses are an indicator of water quality in addition to providing habitat benefits. So with the transect data, we want to, again, link it back to the water quality data so we can better understand which water quality conditions support seagrass growth, as well as understanding how nutrients, phytoplankton, and seagrass relationships change over time to better protect bay resources. So to wrap up, we want to thank our partners, of course. This long-term data set would not be possible without your continued efforts. And training is really important to make sure that this long-term data set continues to have relevance over time. This information is really critical for how we understand bay response to different stressors and how management response can change as a result of better understanding these responses. We have some resources here that basically will provide you different sources of information for inputting data, accessing the data, and some technical information about how this information is collected and how it's been analyzed in the past and how it informs moving forward for management. Thank you all for your continued attention and work over time to collect these data. And thanks, of course, to the TBEP team for facilitating this work and working with you all to support training efforts.